Welcome back, everyone. We are going to find the ratio H2 to H1 in this figure. Let's get started by labeling the vertices by A, B, C, D, and E. This question can be solved by finding the similarity between triangles. To do this, we draw the height of the triangle A, B, and C to the base of AC and label it by H3, like this. Also, we label the smallest triangle by A, F, and G. Let's use the similarities between the triangles. Here we can see that H1, H2, and H3 are parallel and perpendicular to AD, and the triangles at the left side touch the triangle at the right side at the vertex C, and these two angles are the same. Now let's use the similarities between the triangles. This triangle ABH and AFG are similar because the angle B is equal to the angle F, angle H is equal to the angle G, both of them are 90 degrees, and angle A is the common angle between two triangles. As a result, these triangles are similar, and we can write the ratio of H3 to H1 is equal to the ratio of their hypotenuse, AB to AF. AB is 7 and AF is 3. That's why the ratio of H3 to H1 is 7/3. We can simplify this equation by multiplying both sides by H1, like this. And if we cancel out H1 from the left side, we get H3 as 7/3 times H1. We can apply the same proof to the triangles BCH and CDE. The angle H is equal to the angle D. Both of them are 90 degrees. Also, the angle alpha here is equal to the angle E. And as mentioned, the angle C is the same in both triangles. The vertex C is shared between the two triangles. These two have the same shape but different sizes, so they are similar. Therefore, the ratio of H3 to H2 is equal to the ratio of hypotenuse, BC to CE. If we substitute BC and CE values in this equation and multiply both sides by H2 like this and cancel out H2 from numerator and denominator at left side, we get H3 as 10/6 times H2. So now we have two equations for H3. That's why the right side of these two is equal. Now we can find the ratio of H2 to H1 by multiplying both sides of this equation by 6/10 H1. 6 and 10 from left side and H1 from right side can be cancelled out. Also, the ratio of 6/3 is 2. For the left side, we get H2/H1, and for the right side, 2 times 7 is 14, and denominator is 10. So H2/H1 is 14/10 or 1.4. So the ratio of H2/H1 in this figure is 1.4. If you find this useful, please subscribe the channel for more videos. Thank you for watching.